Welcome to solverfy.
In this question, we want to know what would happen if something were to change regarding our sun. So whether the output were decreased dramatically, or maybe there was a solar flare or something. Basically, how long would it take for the light from that event, or at least the change in light from that event, to reach the surface of the Earth? And we know that light as an electromagnetic wave travels at our constant c, which is equal to 3 times 10 to the power of 8 meters per second. And we can also find that our distance traveled, our delta x, is equal to about 1.5 times 10 to the power of 11 meters. This is just an approximate value you can search for online. So we know that velocity is defined as a change in distance, delta x, over a change in time, delta t, and that in this case our light, our electromagnetic wave, is traveling at constant speed c, which we know. Now we want to find our change in time. We want to know how long it would take people on Earth to realize something had changed. So let's just rearrange this equation here. And if we do that, we find that delta t is equal to delta x over c. And since we have values for both delta x and for c, we can just plug them in and get an answer. So delta t equals delta x over c, which is equal to about 1.5 times 10 to the power of 11 meters divided by 3 times 10 to the power of 8 meters per second. And this works out to be about 500 seconds. Now, we could leave it that way, or we could translate that into a slightly bigger unit, say minutes. So we can take our 500 seconds and multiply it by a conversion factor, and we know that there are 60 seconds in every minute. So all we need to do is just multiply across, or divide, however you want to think about it. And we find that this equals roughly 8.33 minutes. And that is your answer.